next presenter, Patrick Donnelly, who will be presenting on behalf of his collaborators, Nathan Blanchard, Andrew Olney, Sean Kelly, Martin Nystrand, and Sidney DeMello. Take it away, Patrick.
All right, thank you very much for coming. So in their classrooms, teachers employ a wide variety of pedagogical strategies. They might include lectures to provide new information, or give projects or seat work for students to work on, or they might engage in interactive question, answer, or discussion segments. Those latter ones are an important component of dialogic instruction, which has been shown by researchers to correlate with increased student engagement and achievement. So if we know that this form of dialogic instruction is so important, how can we encourage teachers to use more of it? Well, we need to train the teachers, and teacher training has also been shown to have downwind effects on student achievement. Moreover, giving data-driven analyses directly to the teachers can help them change their teaching strategies, and also has correlations and effects on student achievement. Our long-term goal in this project is to be able to provide a tool that will record the teacher's class session and automatically analyze these pedagogical practices of the teachers, so that we can provide automated feedback that the teacher can use to adapt and adjust their teaching strategies. And in this work, we focus on questions because, well, they're an important part of how the teacher communicates and interacts with the students. And certain types of questions, those without pre-scripted answers, have been shown to increase student engagement. And moreover, those types of questions can then facilitate lead to class-wide discussions, which are an important component of this dialogic instruction. So in this work, we attempt to automatically detect teachers' questions directly from an audio recording of a live classroom session. So what are these questions like? Well, we could hope that they're just a clear, well-formed question, such as this one.
How does the author use language to create humor?
But in reality, rarely are they spoken so clearly and orderly. Often they're informal.
And what's his nickname?
Teachers trying to interact with the student. That's a little sing-songy and definitely not the teacher's normal speaking voice. Often they're interrupted, perhaps by a student or a noise, or perhaps by the teacher's own thoughts.
What does it clean off of our teeth?
So that one was only a little bit of backtracking, but often the teacher might stop and rephrase, or might be interrupted by a long pause. These questions might take a form of just a continuation from a question that was already posed.
What else? Nathaniel.
And here the teacher is just asking someone to follow up on some previous question that another student has potentially answered. And we all think of questions, we think of question words, but not all questions contain those.
Is it sometimes confusing? Is it a struggle?
And not all questions are exactly questions. Sometimes the teacher calls directly on a student to solicit an answer.
Talk more about that.
So that's something we'd all recognize as a question, but from the words themselves, doesn't really sound like a question. So as we can see from these examples, questions in classrooms differ from other information-seeking activities, such as office meetings or phone conversations, in which the questions might be a little more structured and well-formed. We're dealing with real-world noisy data. That might be the teacher breathing heavily into a microphone, or shuffling papers, or an interruption by a student, or a really loud air conditioning unit in the back of the class. And all of these just pose a lot of challenges in trying to identify these questions directly. And as we saw, some of these speech is very conversational and informal, as the teacher's thinking on his or her feet to adapt to a previous answer from a student. Unlike other work in identifying questions, we don't have the benefit of a perfect data set that's been segmented by humans into questions and non-questions. We have this one recording that we must automatically segment, and that's an imperfect and ongoing research question in itself. Likewise, we don't have perfect human transcriptions of the class sessions, and we must use automatic speech recognition, which is imperfect, in order to come up with transcriptions of what was said. So what we did is, over the course of a year, we went into 8th and 9th grade classrooms for 11 teachers at 6 schools in civics and language arts classes. We fitted each of these teachers with a wireless headset microphone, shown here, which is a low-cost microphone that allows the teacher to move about freely in the classroom, so they can go to the back of the room or help students and aren't tethered to the front of the classroom, which we are hoping are minimally disruptive to the teacher's normal teaching routine. We recorded 37 class sessions. They were between 30 and 90 minutes each, with an average of about 60 minutes. And in each of those, we sent in a trained observer, which used specialized software to analyze the teacher's instructional practices over time throughout that class session. Here's a snapshot of what that software looks like. And it allowed the trained observer to label the larger instructional activities the teacher is using, the lecture, the seat work, or the question-answer sessions. And whenever the teacher posed a question, the observer can mark the question and type a quick transcript of it, which we can use in training our models. And once the observer had left the classroom, he or she consulted with the other trained observer to iteratively refine their codings until there was complete agreement between 2 observers. And overall, of the teacher's speech, we found about 36% of the utterances were questioned, and 64% were non-questions. So I'm going to talk about these steps in more detail individually, but just as a general overview of our approach is we take that classroom recording of the entire class session, and we must partition the teacher's channel into smaller units of teacher speech, which we call utterances. So we segment the teacher's audience into these utterances, and we use automatic speech recognition to filter out some that don't contain speech. And then from those, we extract 3 different types of features, which I will talk about. Linguistic features based on the words of the transcripts, context features such as timing, and acoustic, prosodic, and spectral features directly from the audio. And we use these 3 features to attempt to identify these teacher questions. So first, we got to go from that big audio file into these individual units of teacher speech, these utterances. And we use a voice-activated threshold to detect when the teacher starts speaking, and then when the amplitude envelope falls below a certain threshold for 1 second, we assume the teacher has stopped speaking. And using these speech and rest patterns, we're able to segment the audio into these utterances. However, we do capture some other noise, so we filter them using an automatic speech recognition agent. And for all those utterances that returned some speech, we classified those as teacher utterances, and we discarded any that did not contain any speech. Following this procedure, we ended up with 10,000 speech utterances, and the average speech utterance was about 5 seconds long, although there was some shorter and longer ones. In previous work, we ran a validation study on this approach, where we checked 1,000 of these utterances that were manually coded as containing speech or not, and we achieved an F1 score of 0.97, which we deemed adequate enough for the purposes of this project. So now that we have these teacher utterances, we run them through automatic speech recognition. We use 3 commercial speech recognition systems: AT&T, Microsoft's cloud-based Azure, and the web-based Bing speech recognizers. Each of these speech recognizers have different strengths and different weaknesses, so we seek to leverage that by combining them. For instance, a feature, say, does it contain the question word why? Say 2 of the speech recognizers recognized the word and 1 did not, then we would give that feature a weight of 0.67. And that's just our way of using the information from all 3 speech recognition systems. In a validation study, we looked at 1,000 of these utterances, which we had human transcriptions to compare with. And we looked at 2 common automatic speech recognition metrics: word error rate, which is a sort of edit distance between the true transcript and the hypothesis based on edits and substitutions and deletions, and simple word overlap, which asked how many words in our hypothesis were actually in the transcript. And we see that there's a difference between the 3 different speech engines, but overall, we're only getting like about 50% of the words correctly, because this is noisy and informal speech. So then from those speech utterances, we need to extract our features for our machine learning algorithms. The first type of feature we extract are natural language features, linguistic features. And these come from those automatic speech transcriptions. We use a natural language feature tagger, which was developed specifically for identifying questions in educational contexts. Some of these features might include the presence or absence of question words, such as what, why, where, how, when, or anything starting with a WH. Does it contain certain parts of speech, nouns, verbs, adjectives? Using keywords to determine certain hypothetical categories. Is this a definition? Is this a comparison? Or does the utterance contain any proper nouns or pronouns, for instance? And from this, we have 37 different linguistic features. Next, we look at acoustic, prosodic, and spectral features. We use the Open Smile toolkit to extract these features using a common feature set from the Inner Speech Emotion Challenge. From those features extracted, there were 12 statistical functionals, which gave us a really large set of 384 features. Some of these are related, so we ran a multicollinearity analysis to reduce these acoustic features down to 168 features. Some of these features might be the volume level or the counts of the zero crossing. We looked at spectra using the common Mel frequency celestial coefficients and the first derivative. Then we also looked at some prosodic features such as the fundamental frequency and the probability of voicing based on autocorrelation of the power spectra. And all in all, we end up with 168 features. The third set of features are contextual features. These are things like timing, how long is the teacher utterance? The previous utterance, how long was that, as well as how long is the subsequent utterances? The length of the duration of the pause before or after the utterance. Where is this utterance in relationship to the class? Is it near the beginning, the middle, or the end of the class session? How fast was the teacher speaking? How many words per minute was the teacher speaking? And we have 13 of these context features. So using these 218 total features, we built our machine learning models. We first standardized these features on a teacher-by-teacher level, and we built a number of machine learning models. We tried a lot of common models, k-nearest neighbor, support vector machine, Bayesian methods, and in our preliminary testing, our decision tree was the best performing model for this task. Well, because our data set is skewed with about 2/3 being non-questions and 1/3 being questions, we wrap this with a meta algorithm, the meta cost algorithm, which assigned a double penalty for missing a question, which is the class label we care about finding, as opposed to missing a non-question. So it's more expensive to miss a question. For cross-validation, we did a rigorous leave one teacher out validation. That means we took all our teachers except for one and trained our models and tested on that held out teacher. And we repeated this process for all of our teachers and averaged the results. This is important because our end goal is to generalize to any possible classroom and any teacher, and we don't want certain elements of one teacher to be influencing our result, being in both the training and testing. And we focus on the F1 score of our results, which is important information retrieval metric, which balances information, precision and recall. So if we look at our results, here we have 7 different models. On the left, we have the 3 that show each individual feature set, the linguistic, the acoustic, or the context. The next three show a pairwise combination of those three feature sets. And the final one represents all three feature sets together. And this is the result just for the question class at the moment. And what we found is that the linguistic features were the most important features in detecting questions, as probably doesn't surprise very many of you. But the acoustic features were not particularly well adapted at finding the individual questions. When we look at the non-questions, we notice the linguistic features do well, but they don't help quite. But the acoustic features help quite a bit in detecting the non-questions. And moreover, when we look at the overall results, we notice that the combination of linguistic and acoustic features together were the best in overall differentiating the questions and the non-questions. We wanted to look at the individual features. And so we ran a model containing only a single feature to see if one individual feature was perhaps dominating our results. And although we might have found that for the non-question class, we see the lowest line, the light gray line for question, we did not find a single feature that was dominating. And therefore we needed the combination of the different features in order to improve our results. Along that line, when we look at the top 10 features we have, we see that 7 out of the 10 are natural language features. And the best performing feature was the presence of the question word what, which probably doesn't surprise many. So if all the teachers could always just use what in all of their questions, we'd be in much better shape. But we see some other important things, the phrase do have, or the keyword be, or whether they're using a proper noun, maybe calling on a student or a certain topic from the class, or the use of a pronoun, or the presence of a verb. And then rounding out the list, we see a couple acoustic features. So although we cross-validated based on the leave one out teacher, we wanted to make sure we weren't just succeeding really well on some individual class meeting sessions and failing on some others. So we looked at our results on a class session level. And here we see the distribution of the individual class session results. Indeed, we do a little better on some and less well on others, but overall it's a nice distribution. We don't have just this disjunction between failure and success. Similarly, we have a similar distribution for non-questions of pattern. But for questions, we still have a nice distribution. We have a few more instances of difficulty, and in our post-analysis, it's because these sessions often contain very few questions. The teacher's doing a different activity or worksheet or something, and there's only a small handful of questions in that entire session. So what we have done is we've created a large data sets of recording of classrooms using a non-invasive and cost-effective method of recording the teacher. We've automatically segmented and transcribed these classroom sessions into individual teacher utterances, and we looked at 3 different modalities of types of features to attempt to classify this task. And we validated our models independently of the teacher in order to improve generalization in the future. And what we found is the words do matter. Linguistic features are the most important in detecting questions. But those won't work alone, as they had difficulty with the non-questions. So we need the acoustics and the contextual features to classify the non-questions. So we have a few limitations. We have data from only a single US state, which is a common core state, which might influences the teacher's lesson plans. We've only reporting results of a single classification model, and we, at this moment, only have recordings of the teacher. Well, we're still actively working on this project, and we have another year of data that we have collected, which we will use, and we recorded a general purpose microphone in the classroom so that we can catch some aspects, not the individual students, but we can have some of the students' speech where we can model some dynamics of turn taking between teacher and the student audience. We're going to look at additional classification model, perhaps some ensemble techniques between our 3 different feature sets, as well as we're actually working on temporal modeling using long, short-term memory recurrent neural networks in order to look at these individual questions in the context of the larger class. And in additional work, we're looking at trying to identify specific question properties. Can we identify those unscripted questions that are the most important to dialogic instruction? So I want to acknowledge and thank our collaborators and acknowledge our funding source. Thank you very much.
Thank you, Patrick. Questions for Patrick? Start over here.
Thank you for this interesting talk. So first question. So when the teacher asks a question, so he or she has to wait for the answer. So wouldn't silence be a good indicator that the question has been asked previously?
Yes. So the question was, if the teacher asks a question, there's often silence, or the student's potentially responding, and isn't that a good indicator? So it turns out that we do have that length of pause after a question as one of our tasks, but it's not quite as useful as we might hope, just because questions are a small part of the larger class, and there's other things that have a similar dynamic. The teacher's giving instructions and pauses to look at the class notes or to hand out papers, or there's just other things that are going on that might have a similar pause. So that's why we're going to take this student microphone data, and we can get some activation from a class. So we're going to try to break into that, and is there some type of response happening, and use that turn-taking dynamic. Thank you.
Yeah, it's really fascinating stuff. I have a couple of questions about some of the methods. So one is, can you tell us a little bit more about the NLP feature extraction process? Like, you have 37 features, which is a lot less than like bag of words, right? And some of them seem pretty complicated, right? Like, I could figure out what, but some of them there's a lot of packaging going on. So I wonder how you do that. And also, have you thought at all about taking different question types?
Yes. So the first part of the question is a little bit more about our linguistic feature extraction process. We specifically avoid a bag of words process because we might be recording a topic where they're talking about the Civil War, and there's all these terms that are only going to come up once, and it's never going to come up in a different classroom or even the same teacher's classroom the next day. And so these features we use are from one of our collaborators who was developing these features specifically for identifying question properties. And some of them aren't quite as complicated as you think. There's the keyword what, but in terms of making a comparison, it's looking for certain keywords. Is there an if and a then? And so there's certain keyword analysis which might flag, I believe that's a Boolean feature that turns that on. And they're hypothetical, and we're trying to guess if that's the case or not on one of those. And the second part of the question was, are we looking at certain question types? Indeed, we are trying to identify specifically authentic questions, which is when the teacher gives a question without a pre-scripted answer, as opposed to a test question where there's an expected response. And those are the questions we really care about, and we've been diving in to identify those as well, so that's ongoing.
It sort of follows up on that. So if you think about the breakdown, so you're finding the easy ones like what they're easy. If you think about the data set, do you have a lot more of those what type questions, so the direct questions versus the more indirect questions, and potentially that's then going to fall into a feature extraction, so you're sort of almost waiting in that way.
Yes, we need to do some more post-analysis to try to break that down, and that's when we might look at certain ensemble techniques, one that looks specifically for the question words and might be weighted, and then one that tries to get at other types of questions, we might weight that more in an ensemble technique. So that's something active we're going on to try to break it down. I don't have that with me, but I could email that to you. A lot of, there's not quite as many as you thought. It was at 0.68, but it's not 2/3 of the question with what. If I remember, it's something, it's a much lower number, in the 20% or something. It might have what.
I'm gonna go up to the front and then to the third row.
Yeah, for the linguistic extraction, are these rule-based, or do you have like a model that's trained to find out what are these keywords, like what?
Right now, they are a rule-based set of certain keywords. We're looking at expanding that to try to automatically identify things like certain proper nouns. Can we differentiate between topical nouns? And we'd really like to know student names, have model student names, and certain elements like that. So that's ongoing as well.
Here in the third row.
Yeah, I have a question about the coding and labeling process. If I understood correctly, there were two people who assigned question, non-question labels. And you said that happened until there was agreement. Did you capture when they disagreed? And I'm just mostly wondering about what sort of the prevalence of things that may or may not have been put, like cleaning a question or not in your data set, and how much of that happened that was captured.
So a lot of that was because the live coding of the person who's sitting in there. So a lot of that refinement, there wasn't a lot of disagreement with. It was an artifact from going quickly and those types of. But when we looked at an analysis between the coders, I believe we had a cap of about 0.85 agreement between them. So it was pretty high, and I think they just negotiated things until there was agreement. And I'm sure in a few cases one yielded to the other, but I don't think they were coming to blows in terms of disagreement and splitting hairs and those types of things.
We'll
Yeah.
go here, and then here, and then here. Go ahead.
Interesting presentation, thanks very much. But what about physical manifestations of communication? We don't get from audio recordings as facial expressions. You do get a bit from tone, but even then you don't really get from that. So doesn't it constrain to a certain extent in the way these interactions are?
Potentially. So so he's asking about our modality of audio. Is that limiting? We would like to do videos, but there's a whole host of privacy concerns with recording middle school students. And so some other research has worked on that, and we're trying to have a very low-cost method to accomplish this. So while video and those specifically having facial recognition or connect for skeletal movements, all those things would indeed help. We're trying to do it in such a way, how much leverage can we get out of this simple audio format?
Thank you. I'm just wondering whether you have any intuitions about future application for your work. In particular, I'm thinking of teacher education. Do you think you could classify questions from the teacher in terms of the quality of the response it elicits from the students to assist in educating teachers?
Absolutely. So the question was about what are our long-term goals with this, and specifically in how we're giving teacher feedback. And that is indeed the goal. We want to make a tool where the teacher can just, in a low-pressure situation, record this, their leisure after class, review this. They'll get a percent. They spent 30% of their time on question and answer. They asked 15 questions, maybe 5 of those questions, or 1/3, were of these authentic questions that we care about. We're hoping to get those kind of simple things first, and then long-term it'd be interesting to delve into the quality of the student response. We don't have the fidelity of the student response to do that because we're not, for privacy concerns, recording individual students. We just have a single microphone, so we get kind of student activation or not. So that might be a little bit difficult to do specifically on the quality of the response. But long term, we could potentially extend this if we can overcome some of those privacy concerns.
Up in the front.
My question already asked.
Okay, and I think we have a question there. No? Yes, right there.
Did you look into sort of just boiling that down into number of teacher questions per hour or per day, something like that across the teachers, and then kind of compare it back to the performance of the whole class in general? Like, is it the hypothesis in the beginning, like, hey, if teachers ask more of these kinds of questions, we're going to get better learner outcomes? Have you been able to sort of see that strongly?
So that's indeed what we're hoping to do. We just don't have those results quite finished yet because we have another year of data that is kind of our test set of data on that, where we took a pre-test and a post-test, and we're looking at student achievement, and we're going to try to see how well those rates affect on student achievement. So we have a whole educational social scientist on part of our team who's working on that aspect. So those will be forthcoming.
We have time for one last question, if it can be answered by a quick answer.
My question's not quick.
Try.
I wanted you to talk about a little bit more about what you meant by authentic questions and why do you care was the theoretical premise. Originally I had the same question, but I thought you might be looking at like depth of question.
So I use that phrase, authentic question, and she's asking to expound upon that a little bit more. So there's a test question, like what is the capital of Spain, where we got a simple result that's expected. So those aren't shown with the student achievement and engagement results. So an authentic question is an open-ended question where the teacher might not have a prescripted response. And so, like, why do you think that this author said such and such? And the student can then expand upon that, and then the teacher might ask follow-up questions, which is something called uptake, which might incorporate part of the student's response into the follow-up question. And so those are the types of interactions that lead to a classroom-wide discussion and have really been shown to increase the student engagement, have downward effects on student performance. So of our questions, ideally we want to identify the specific authentic questions and encourage teachers to use more of that dialogic construction.
Isn't that just the Socratic method?
I mean, yes, it goes along with the critical thinking, absolutely,
You
which
two
Common
together
Core
for
might
lunch.
not.
Let's thank Patrick one more time.
Thank you.